Chapter 7, we are going to dive into polygons, specifically in this section, the angles of polygons. So we need to start off with understanding what a polygon is. A polygon is a closed figure, meaning that it has no openings. So that would not be a closed figure because this side is left open. It also consists of all straight lines. So you've seen polygons your whole entire life. We have triangles, we have four-sided figures, five-sided figures, all examples of polygons. So we're specifically looking at the angles of these polygons. So the first one we're going to look at is a triangle. We already know all about triangles. It's primarily what we've been working with this year in geometry. So a three-sided figure is called a triangle. It has three sides, it has three angles to match that as well, and it is 180 degrees, as we have been forced to use over and over and over again this year. Well, we're going to use that very known concept to figure out how many degrees are in any sided polygon. So a very general four-sided polygon is called a quadrilateral. We know a lot of types of quadrilaterals. You know squares and rectangles, parallelograms, and even more. So the general name of a four-sided figure is a quadrilateral. It also consists of four angles. So I want to figure out how many different triangles there are within a quadrilateral. If I know how many triangles there are, then that will tell me how many degrees. So I'm going to start at one of the angles and I'm going to draw what is called a diagonal. So a diagonal connects to all other angles that does not create a side. So I could connect to this angle, but it's redundant because I already have an orange side. I could connect to this angle, but it's redundant because I already have an orange side. So I'm just going to go straight across. So there is one diagonal, which means we have two triangles. Well, if we have two triangles and each triangle is 180 degrees, that means that a quadrilateral is 360 degrees, which makes sense because if we think about rectangles or squares, each of those angles are 90. 90 times 4 is 360. A five-sided figure is called a pentagon. 5 sides, 5 angles. We're going to go through the same thing. I'm just going to choose one random angle, and I'm going to connect to all other non-adjacent angles. So there are three triangles in a pentagon. So we have 1, 2, 3 different triangles. So we have 3 sets of 180 degrees. 3 times 180 is 540 degrees. So a pentagon, it is 540 degrees. A 6-sided figure is a hexagon. Going through our same routine, drawing our diagonals. So I picked this random angle. I'm going to draw a diagonal to all non-adjacent angles. And if I count, I have 1, 2, 3, 4 triangles. 4 times 180 degrees to represent those 4 triangles is 720. So as you can probably tell already, every single time our side increases by 1, our number of triangles increase by 1, which means the number of degrees increases by 180. So we could continue to draw diagonals for every single figure. A 7-sided figure is called a heptagon. A lot of students like to think it's a septagon, but it is a heptagon. To every non-adjacent angle. But we should already know that the pattern is going to leave us with 5 triangles and 5 times 180 is 900 degrees. So all heptagons is a total sum of 900, just like all triangles is a total sum of 180. An octagon is an 8-sided figure, 8 sides, 8 angles, and we're going to skip our diagonal step because we know it's going to have 6 triangles within, and 6 times 180 degrees is 1080. A 9-sided figure is a nonagon, and we're going to skip our diagonals again because there are 7 triangles within a nonagon, and 7 times 180 degrees is 1260 degrees. So there is a general formula for finding the degrees of a polygon. So if you notice, the number of triangles in a figure is always 2 less than the number of sides. So a 5-sided figure had 3 triangles. A 6-sided figure had 4 triangles. A 7-sided figure had 5 triangles. So in order to find the measure of interior angles, we're going to take the number of sides, that's what N stands for, subtract 2 from it, and then we'll multiply that by 180 degrees. So if I want to find the number or the sum of the measures of all the angles, just like I always know a triangle is 180 of this certain figure, I need to know how many sides there are. So there's 1, 2, 3, 4, 5, 6, 7, 8. I'm working with an octagon. So I could just go back to my list and see, okay, an 8-sided figure, well, that's this many degrees. If I don't have that list on me, however, though, I can use this formula. So I plug in 8 minus 2. I'll multiply that by 180. 8 minus 2 is 6. And 6 times 180 degrees gives me 1080 degrees. So this figure on the inside contains 1080 degrees. The next example is the reverse of that. We know that the sum of the interior angles, the answer is 900 degrees. We want to know how many sides there are. So the number of sides is missing. So we're going to use that same formula, the number of sides minus 2 times 180, and we're going to set it equal to the sum total of 900 degrees. Once again, if you have this list, you can just look back and see, well, which one of the figures is 900 degrees. But if you don't have that list on you, you're going to solve. So I'm going to work backwards. I'm going to start outside the parentheses. Since it's multiplying, I'm going to divide by 180 on both sides. So I'm left with the quantity of n minus 2. And then 900 divided by 180 is 5. Add 2 to both sides, and this is a 7-sided figure, which is a heptagon. We can apply this knowledge to solve problems. So I want to find the value of x. In order to do that, I need to know what all of these angles are going to add up to. So I have a 1, 2, 3, 4-sided figure, so I'm looking at a quadrilateral. So I can plug that into my formula, 4 minus 2 times 180. So I'm looking at 2 times 180, which is 360 degrees. So now I know the sum of the 4 angles is going to add up to 360. So x plus 108 plus 121 plus 59 equals that sum of 360 degrees. I'm going to combine my like terms. So 108 plus 121 plus 59 is 288. And then my last step is to subtract the 288 from both sides. So x is 72 degrees. So we talked about the interior of any polygon having the special formula of n minus 2 times 180. And the interior sum will change depending on how big or small the number of sides are. Well, the exterior angle sum is used for every single polygon. So whether it's a triangle or a decagon, every single shape, the exterior angles always add up to 360 degrees. So you don't have to figure out some formula to determine how many angle degrees the polygon has. Whenever we're working with exterior angles, so that means they're on the outside, no matter how many there are, the sum will always be 360. So in this case, we have 2x plus 67 plus 89 is equal to that exterior sum of always 360. Combining like terms, I do have 3x when I add x and 2x. And then when I add together 67 and 189, I have 156. Then a normal two-step equation. Subtract that 156 from both sides. So 3x is equal to 204. Then we're going to divide that out by 3 to get x is worth 68 degrees. The last thing we're going to talk about is a regular figure. So regular means that every single side and every single angle is going to be exactly the same. And we've worked with these specific types of regular figures. We just haven't called them regular. We've worked with equilateral triangles. That is a regular triangle because every single side is the same and every single angle is 60 degrees. A quadrilateral that is regular is a square because every single angle is the same and every single side is the same. So we're looking at a dodecagon, which we haven't actually learned how many sides a dodecagon is. So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're looking at a 12-sided figure. So that means there are 12 sides and 12 angles. So part A wants us to find the measure of each interior angle. Well, when we're talking about interior angles, we need to use that formula, n minus 2 times 180. So there are 12 sides, subtract 2, and we will multiply that by 180. 12 minus 2 is 10, and 10 times 180 is 1,800 degrees. That's the sum. However, they want to know the measure of each interior angle. So we know there's 12 angles, so we're going to take that 1,800, we're going to divide it by 12, and each angle is 150 degrees. Regular means every single angle is going to be the same exact degree all the way around this trampoline. So they're all congruent. Part B, find each exterior angle. So we know that all exterior angles is 360 degrees, and there's 12 angles. So I'm going to take 360 degrees, and I'm going to divide it by 12. 360 divided by 12 is 30 degrees, which makes sense because if I were to extend this side, all right, I know this interior angle is 150, so the exterior angle has to be 30 because the sum is 180 of a straight line.